This simulation is series versus parallel circuits. So the purpose of this activity is to observe the difference between series and parallel circuits. So there's this simulation on the references, and you can see I have that pulled up off to the right. This activity is going to cover resistance, Ohm's law, series, and parallel circuits. So if we look at the instructions for each section below, design the circuit that is shown, measure the voltage and current at the different points in each circuit. So I'm not going to bother reading all these instructions here because it's just basically showing you how to make the circuit. So I want that intro to circuit design, and I'm going to make the series circuit. So this is how I operate. This one, I get the battery here, and you can also see off to the right, I do show you how to make the this settings box. So I want values, and I want conventional current. And you might be able to see down here, yeah, you can edit the battery voltage, but the battery voltage is going to be set at 9 volts, just like a 9-volt battery. All right, then I'm going to place a switch here. Then I need a resistor, right? I need it to be 10 ohms. It's already set at 10 ohms. Then I'm going to get another small little wire here. Then I'm going to get another resistor. Now this resistor needs to be at 20 ohms. So I click on this. You can see there's a little slide rule down here, and now it's at 20. And the last one is going to be 30 ohms. So I'm just going to place another little wire there, and I'm going to place it in series. I'm going to place it vertically. Then I can click on this, make it 30 ohms. There we go. Oh, all right, perfect. So you can use the arrows, but it only goes up by 0.1 ohm. All right, then I just need to connect it with the wire here, and there we go, right? So that is the circuit. Now I'm going to be using this voltmeter to get the voltages, and I want this black lead at the negative end, this the bottom end of the battery, because that'll tell me the voltage, which is basically the difference in electrical potential, right? So this will tell me the voltages at different points. And I have this ammeter. This is going to measure the current. So I'm going to be able to measure the current through different points. So you can see on the picture on the assignment, there is 4 different points and 3 different resistors. So we are going to measure the voltages at those different points and the current through all of those different points. So I'm just going to go ahead and flip the switch, and you can see that the current is not flowing. Is it not connected? Oh, sorry, there it is. Yep, you got to make sure that it's connected. There we go. So that's just one thing. If it doesn't flow, that means that you do not have a connection, because that's what you need in order for current to flow. So some of them can be a little tricky. So now what I'm going to do, I mean, this should be fairly easy, right? I just go to point A. There we go, 9 volts, right? 9 volts. Perfect, right? You just do those different points. Then you can do the current at different points. I'll do the current at point A, 0.15 amps. Perfect. Now, I've noticed that it's a lot easier and a lot quicker to just do the voltages at once. You can take that lead, and then you just go to the different points, enter it, and then you take the ammeter, just go to those different points, and you will be able to get those measurements real easy. The one thing is that we're going to measure the current through the resistor. Now, when we're measuring voltages, we're sort of measuring the voltages at a certain point or across a resistor, right? We're comparing it all to the ground on this one, or the bottom side of the battery, the negative end of the battery. But like, you can measure the current through the 10 ohm resistor down here. But you don't want to. You can't really measure the voltages through at resistors, right? You measure voltages at certain points in the circuit, right? So you're going to go ahead and do that for all the different points. Find the voltages and the currents. Then what you're going to do is you're going to do the same thing, and you're going to make the parallel circuit here. So we still have the 10, 20, and 30 ohm resistor, but you can see now they're parallel to each other. So I've already constructed this one. That way I don't have to spend a lot of time making it. So I'm going to go ahead and just flip that switch again, right? And we want my voltmeter. Once again, that black lead is at the negative end, right? And I'm just going to do point A, right? So you can see point A right here. Perfect. 9 volts. So point A is 9 volts. There we go. And the current at point A, come up here. There we go. And 1.65. There you go. 1.65. Perfect, right? Now, once again, remember, you're not going to be able to measure the voltage at or like at the resistor. We measure the voltages comparing 2 different points, as basically measuring the electric potential between those 2 points. We're just comparing every point to the negative terminal of the battery. And if you put the lead on the resistor, it's not going to work. That's why we're not getting the voltages at the resistor, because we're measuring voltages across the resistor. But you can measure the current through the resistor. So if I come down here to the 10 ohm resistor, well, I can measure it, right? So the current through the 10 ohm resistor is 0.90 amps. And once you complete this at those different points, you should be able to answer these questions below, right? So what we're doing is we're comparing series and parallel circuits in terms of whether the voltages at those different points and currents through the resistors are going to be the same or different in that circuit. So you can see there's just like the voltage across each resistor in the series. Is it going to be same or different? The current through each resistor, same or different. Then you do the same thing for parallel circuits. Then the last couple of questions sort of ask you to put it all together, right? Define what a series circuit's in terms of voltage across the components and current through the components in a circuit, and define what a parallel circuit is in terms of voltage across components and current through components in the circuit. And you can see the hint that I give you is kind of a big one. It talks about Ohm's law, right? That's one thing that we're talking about when we're putting together circuits. Ohm law states that the voltage drop across a resistor is equal to the current times the resistance. Compare these variables to water. The voltage would be the water pressure, the resistance would be the thickness of the pipe, and the current would be the flow rate of the water. So if we're looking at like a series versus parallel circuit, right? That last sentence is different in a series circuit. How many paths does the current flow? And in a parallel circuit, how many paths does that current have the option to flow through? So with all of these, with all the data tables and the questions, you should be able to come up with the definition of a series circuit and a parallel circuit. So once again, this simulation is series versus parallel circuits.